this tutorial, we're going to be creating a Python script that will allow us to chat with any PDF we pass to it. We're going to be harnessing the power of Gemini API coupled with Langchain and Chroma DB to create this system. For the purposes of this tutorial, we're going to be training on system on the financial report of Best Buy for the year 2023. A link to the source code and all of the resources that I mentioned within this video is going to be down in the description, so you can download the source code if you want to see what the final product is, or if you want to get access to the resources that we're using. But basically what I'd like to do right now is basically ask the CLI tool that we're going to be creating what the net earnings for Best Buy were for the year 2023. So I can say what were the net earnings for 2023, and then let's wait for the answer. But at the same time, I'll just like to quickly show you that the net earnings for year 2023, according to page 31 on the report, is $1,419 million. And as you can see, it tells us here as well that the net earnings for the fiscal year that ended on this date were $1,419 million. So it was able to deduce this information by taking into consideration the actual context that we gave it from this PDF, and then combine that with the actual LLM that we're using, which is Gemini, and then generate an appropriate answer for us. So we're basically creating a RAG-based system. So to get started, what I've done is just open up an empty folder within Visual Studio Code, created a virtual environment, and then activated that. So what I'm going to be now doing is installing all of the dependencies that we require in order to write our code. So there are going to be a couple of things that we're going to be using. The first thing that we're going to be using is the Gemini API, which is going to allow us to interact with the Gemini LLM and then give it the appropriate context as well as our query so that it can generate an appropriate response for us. So what you're going to be doing is coming to ai.google.dev/, and then what you're going to be doing is basically clicking on the button which says Get API Key in Google AI Studio. And within aistudio.google.com, you're going to come to the section which says Get API Key, click on Create API Key, follow through the actual steps, and then you should have the API key with you. Once you have the API key, the next thing that we're going to be doing is coming back to our actual code editor of choice. Here, I'm going to be creating a new file, and I'm going to call this rag.py. And this is going to be the actual file which is going to be responsible for giving us the interface for our command line tool to ask questions on our PDF. And for now, we'll do the following. We'll just basically say that our Gemini _API _key is going to be equal to, and then whatever our key is. In my case, what I'm going to be doing is copy pasting my key in, but just as a quick side note, this is not going to work by the time this tutorial comes out since I am going to be deleting it. Once we have our Gemini key set, the next thing that we're going to be doing is installing all of the dependencies. So we're going to be using Langchain, and as you can see, Langchain is a framework for developing applications powered by large language models, LLMs, and it simplifies the process for us to create these complicated systems. So to install Langchain, all we're going to be doing is doing pip install Langchain. So I'm going to do pip install and then Langchain. And then I'm going to wait for this process to complete. While Langchain is installing, the other dependency that we're going to be using is going to be Chroma DB. Chroma DB, as you can see, is an AI native open source embeddings database. And what this database allows us to do is basically store embeddings within it. And you can think of embeddings as a vectorized version of the actual content of our PDF. And this database specializes in storing those embeddings. So what we're going to be doing is basically taking our PDF, ingesting all of the information from it, converting that into some kind of a vectorized form, we can call them embeddings, and then saving those embeddings within the Chroma database. So the next time when we have to, for example, retrieve some information regarding a specific question that we ask from the actual PDF, then the actual similarity search that's available to us on Chroma DB is going to help us with that. So you don't have to worry too much about what's going on for now. Just basically go ahead and make sure that you install Chroma DB. So to install Chroma DB, all it's going to be is getting started, and then you are going to do pip install Chroma DB, as you can see. So let's copy this, come back, make sure Langchain has been installed, and then we can do pip install Chroma DB. Besides this, we're also going to be using the PyPDF package, and PyPDF is a Python library that's going to allow us to work with PDF files. So let's copy this. So now that Chroma DB has been installed successfully, the next thing I can do is pip install PyPDF. And while PyPDF is installing, we can move on to our next dependency, which is sentence transformers. And sentence transformers is basically a package that is going to allow us to generate embeddings from actual textual content that we pass it. So this is going to be another important part of our actual application. So let's copy this command And let's come back, make sure that the last command for PyPDF finished, and then we can start installing sentence transformers. And then the last thing that we're going to be using is going to be the Google Generative AI package. And this is the actual Google AI Python SDK that is going to allow us to interact with the Gemini API. So let's copy the command for this as well. Let's come back, and then what I'm going to do is wait for the actual process to complete. Just as a side note, links to all of the resources that I mentioned within this video will be down in the description, as well as a link to the source code, so you can download it if you're confused at any point. So now that the actual process for installing sentence transformers is complete, let's do pip install Google-Generate AI, and then we'll wait for this package to actually finish installing as well. So now that we have our API key set up and all of the dependencies installed, what we can do is minimize Google Chrome and start working on our actual system. The first thing that I'd like to do is basically create the script which is going to ingest in our PDF and then spit out embeddings from it and then store those embeddings within our actual database. So for that, let's do this. Let's actually create a file, and I'm going to call this file generate_embeddings.py and then open it up. Within this, I am firstly going to import all of the following imports. So from Langchain_community.vector_stores import Chroma, from Langchain embeddings Hugging Face embeddings, from Langchain.textSplitter recursive character textsplitter, and then from Langchain community document loaders import PyPDF loader. Once I have all of the actual imports configured, the next thing that I'm going to be doing is basically creating a list, and within this list I'm going to do PyPDF loader, and I'm going to load in my actual PDF. So here I need to pass the path to my PDF. So what I'm going to do now is basically reveal the PDF within Finder, and then basically copy and paste that within the actual folder here. So now we have report.pdf available, and the path to report.pdf is going to be /report.pdf. And then what I'm going to be doing after this is creating a list of docs, and then I'll do the following. I'm going to do for file in loaders, and then I am going to say that we're going to do docs.extend, and I'm going to do file.load. There we go. That's all we had to do. So now what we're basically doing is we're setting up our PDF loader, and then what I can do from here is loop over all of the files that are within this loaders list, and for each of the file, load the contents from it and then add that in within our docs list. Now that this is done, our docs list is going to be containing all of the data from all of the different PDFs that we might add within the loaders list. So the next thing that we're going to be doing is setting up our script so that it can actually take this information that is within the docs list, split it up, generate embeddings for it, and save that within Chroma DB. So the first thing that we have to do is basically split up all of the content that we have within manageable chunks so that we can generate embeddings for it. We don't want this one huge embedding, that's the whole embedding for the actual content of our PDF. We'd like to split the content up into small chunks, and for each of those chunks, generate a vectorized representation, aka embeddings. So I can do text_splitter, and I'm going to set this equal to recursive character text splitter, and here we're going to pass it the chunk size. So the chunk_size is going to be equal to 1000, and then there's going to be a property called chunk overlay. So I'm going to do chunk overlay is going to be equal to 100, and that's pretty much all we had to do. So now that we have our recursive text splitter set up, then I'm going to do docs is equals to, and then I'm going to do text splitter dot, and then I'm going to do split the documents, and the documents here is going to be the docs list. There we go. Once this is done, I am actually going to be now setting up the function which is going to ingest these docs in and then spit out embeddings for them. So I'm going to do embeddings_function is equal to, and I can do Hugging Face embeddings, and then here I'm going to do model name, and it's going to be equal to the following model name, which is going to be sentence transformers, and then all -mini lm -l6-vm. So let me just paste that in like so. And then after this, I am also going to be passing in some keyword arguments to the actual model. So I'm going to do model_quarks, stands for keyword arguments. And I'm going to say that to actually generate the embeddings, the device that we're going to be using is going to be CPU. So this is basically going to ensure this script is going to run on all systems, regardless of the fact that whether they have a GPU or not. And then once this is done, all we have to do is the following. I'll create a variable called vector store, and I'm going to be setting it equal to Chroma dot, and then we want to create our database from documents. and then the documents are the docs list, and then the actual function that is going to take these documents, generate the embeddings from it, and then return those embeddings so that they are stored within Chroma. That function is going to be our embedding function. And then finally, I'd also like to make sure that this database is persisted, as is not only going to be within our memory. So for that, what I can do is say that the persisted directory is going to be equal to the following, which is /, and then I can do Chroma _DB _nccn. There we go. And that's all we had to do. So with this done, just to make sure that our vector store is going to have information within it, what I'm going to do is the following, which is once all of the process completes and the actual embeddings have been generated, do vector store dot and then count. So this is going to be the count, as you can see, of how many embeddings we have within our vector store. So let's do save and let's test this script out. So to test the script out, all we're going to be doing is Python, and then I can do generate embeddings.py, press enter. Let's increase the size so that we can actually see what's going on. Welcome back, everybody. So as you can see that I got an error that says that there's nothing known as a chunk overlay. So let me see what the issue is. It's actually chunk overlap. So let's do command save again. Let's try one more time. And let's see if we get an appropriate response given back to us. So I'll resume the video once the process is complete. Welcome back, everybody. So the process actually did complete successfully. The only issue that occurred was in the print statement, where it was actually vector store, and then I need to do _collection and then count on that. And this is basically going to give us a count of how many actual embeddings we have within our collection that is within our Chroma database. So I'm going to do Python generate embeddings.py once again, and I will wait for this process to complete, and then I will resume the video. Welcome back, everybody. So as you can see, the process completed successfully this time. You can see that we have a total of 372 individual embeddings within our actual database, and this means that the actual operation did complete successfully, and that the actual content from the actual report.pdf has now been converted into some embeddings, which are 372 different embeddings. So now that this is done, we can clear this, and as you can see within the actual project source directory, we can see that we have the folder Chroma _DB _nccn, under which we have our actual SQLite 3 database, which contains these embeddings. So the embedding script is done, so we can work on the rag.py script, which is the actual script that is going to give us an interface through the command line, through which we can ask questions on the data that's now within Chroma DB, and that data corresponds to the data that was within our report.pdf. Just as a side note, let's just say that if you wanted to generate embeddings for your own PDFs, all you'll have to do is just basically add those PDFs here. You can add as many as you'd like, and then you just have to run the script again, and that's going to take those PDFs, take the content within them, generate embeddings for them, save them within Chroma DB, and that's all the script does. So now that this is done, within rag.py, the first thing that I'm going to be doing is basically generating a part of the total system that we're going to be creating, which is going to take in the query that the user gives and then spit back to us relevant parts of the actual content that's within Chroma DB that relate to that query. And I'll show you why this is important, but let's just do this first. So to do that, let's do this. Let's firstly create a while loop, and let's do true. So this is an infinite loop, and within this we are going to be doing the following. First, what I'd like to do is basically print a very long line, and then after that I am going to then say that I'm going to print what would you like to ask, and then after that I'm basically going to create a variable query, which is going to be equal to the input function, and this is going to basically take the input in from the user like so. So with this done, then I'm going to do print the query, just so we can see that we're actually taking in the correct data. So now if I do Python rag.py, it opens up the actual tool. As you can see, now it's waiting for us to give it something. So I'm going to see, for example, hi, and as you can see, it prints hi. And now if I do Control-C, we can exit out of the actual script running, and then we can start the next part. So as you can see, when I did Control-C, we didn't exit out of the actual script gracefully. So what I'm going to quickly do is basically import the following modules, which is import OS. And then after this, I'm going to do import signal. And then I'm going to do import sys. And then what I'm going to do is the following. I'll create a function, and I'm going to call this signal _handler. And then I'm going to say that this is going to get a signal given to it and a frame. And then I am going to do the following, which is just print on a new line, thanks for using Gemini, like so. And then I'm going to do sys.exit 0. And this is going to allow us to exit gracefully out of our script. And then what I'm going to do after this is basically say signal.signal. And I'm going to say that for the signal, which is signal interrupt, that's the signal that's given to the script. When we do Control-C, the signal interrupt, we are going to be using our signal handler to actually handle the functionality of what needs to happen when we give it an interruption signal. So now we're doing this. If I rerun the script, you are going to see that if I do python rag.py, everything looks good. I can ask a question here like, who is CEO of Best Buy? But if I do Control-C, we exit out gracefully and it just shows us a message saying, thanks for using Gemini. So this is just some good error handling that we've implemented. So now that we're storing the query within an actual variable, the next thing that I'd like to do is basically analyze what the user's asking us and then basically perform a search on our database to see, hey, if the user's asking us about, let's just say, the gross revenue or gross profit, is there something within the actual database that maybe contains gross profit within it or some information related to that, so that then we can extract this information and then give this to Gemini alongside the actual user's question so that it could appropriately generate a response. So that's what we're doing now. So to do that, I am going to do the following. I'm going to say that I'm going to create a function and I'm going to call this get relevant context from DB. There we go. And then within this, I'm going to say that this function will get the query passed to it. So this is the query that the user gives us. Then I'm going to do the following. I'm going to create a variable, call it context, and set that to an empty string. Then I'll do that. We're going to create our embeddings function. So I'll just copy and paste the same embedding function is, and this is basically the same embedding function that we had used when we were generating the embeddings. All I'm going to do is come to the top and import the appropriate Hugging Face embeddings class. Once this is done, the next thing that I'm going to be doing is basically creating a variable which is going to store our vector database. So I'm going to do vector DB, and then I'm going to be setting this equal to Chroma. And then what I need to do is basically import the Chroma database as well. So for that, I can come to the top and import it from Langchain_community.vectorstores Chroma. Then I can come down and here I can do Chroma, but this time we are not going to be generating our actual database from documents. We're going to be saying that, hey, you need to open up an existing database from this persist directory. And then the name of the persist directory is the following, like so. And then to understand the embeddings, you need an embedding function. So that is going to be the same embedding function as before, which is using the same model name. And then I'm going to do embedding function is equals to embedding function. There we go. So now with this done, what we can do is basically perform a similarity search on our database using our query. So to do that, I'm going to do search results is equals to, and then I can do vector DB dot similarity search. And then here I can do the query that the user passes, like so. And then the amount of actual documents that we're going to be returning. So by default, you can see that K is going to be 4, and this is the number of results that get returned to us, which correspond to our query. So each result is going to be one embedding that's within our database. So I want 6. According to my testing, 6 was a number that I concluded worked good for my use case. So you can experiment with this and see how many results you need to retrieve, but 6 is what we're going to be using. So now that this is done, what I'm going to do is basically go over all of the results. So I'm going to do for result in search results. And then I can do two things. I can take our context and I can append to it our actual result dot page content and then a new line after that. There we go. And then finally, when we get out of this for loop, I can return the context. There we go. Then what I can do is come back, and after we get the user's query, I am going to do the following, which is context is equals to, and then I can do get relevant context from database and pass it the query. So we're basically taking in the question that the user sends us, giving it to this function. This function takes that actual query in or question in, performs a similarity search from this question and the actual information that we have available within our database. And then if it's able to find search results similar to the information that we might be asking, it returns that to us. And then we add to our context string all of the information that gets returned to us for each of the results, and then we return that. So now if I print the actual context, and then if we can do Python rag.py, you are going to see that it asks me a question. I will say, who is the CEO of Best Buy? This information is within our actual report.pdf, and send this query. It's going to take a little bit of time for this to happen, but then it should spit out a bunch of information to us, as you can see. So from the similarity search that was performed, it's basically deduced that this is some of the actual content that relates to the question that we had asked. And as you can see, if we scroll through the context, there we go. There's the information. Corey Berry. She also serves Corey Berry CEO. There we go. So hidden between all of this mound of information, there consists the actual information that we are actually concerned with. So now what we need to do is take this information alongside our actual question, pass this to Gemini, and let it handle all of the actual analytical reasoning of reading through all of this context and figuring out what the appropriate part is to answer our question, and then returning an answer to us. So let's do Control-C to exit out of this. Let's clear, and let's generate the next part of this script. So the next part is going to be to actually create a function that is going to generate the prompt, which we're going to be giving to Gemini. So to do that, I am going to do the following, which is just say that we're going to have a function, and I'm going to say generate underscore rag underscore prompt. And this function is going to take in two things. It will take the query that the user gives and the context that we've generated in the previous step. Then I'm going to say that I am basically going to replace all of the quotes that we have within our actual context, so that there are no semicolons or colons or anything like that. So to do that, I'm going to do escaped is equals to, and then I can do context dot replace, and I can do, for example, replace all of the single quotes with a nothing, and then I am going to do replace, and then I'm going to do all of the double quotes within them with a nothing. There we go. And then after this, what I'm going to do is basically say that this string is going to be single quotes, and then we remove all of the double quotes with nothing. And then finally, I want to replace all of the new line characters with just a space. So I'm going to do replace the new line characters with a space. And this is just for better efficiency of our algorithm and making sure that we can pass as much information as we can. So now that this is done, I just need to generate my prompt. So my prompt is going to be the following. You can work around with this prompt, change it to your likings, but this is basically the instructions that we're passing to the Gemini API for it to understand what the task is. I'm going to split the string over multiple lines, so I'm going to use 3 quotes, and this is going to allow us to have a multi-line string. And then within this, I am going to say that we are going to have the following prompt, which I'm going to copy and paste in. There we go. So what I'm saying is that you are a helpful and informative bot that answers questions using text from the reference context included below. Be sure to respond in a complete sentence, being comprehensive, including all relevant background information. And then, however, you are talking to a non-technical audience, so be sure to break down complicated concepts and strike a friendly and conversational tone. If the context is irrelevant, this is important to the answer, you may ignore it. So if we pass gibberish, just ignore it. If you can't find the answer within the context we pass you, ignore it. Don't give us hallucinations. So this is an important thing. If you want to avoid hallucinations, definitely include this. And what I mean by hallucinations is where the actual response that's given to us is just basically garbage information or information that just Gemini came up with out of nowhere. So then after I've defined my prompt, what I'm going to do is the following, which is say that we are within this actual prompt going to have our question like so. And I'm going to say that the question is going to be equal to, and then I'm going to interpolate my query like so. And then the actual context, I am going to say like so, is going to be equal to the following, which is context. There we go. And then finally, the last thing that I'm going to be doing is, after I've defined both these things, adding a space, and then after that saying answer, and then this. So there we go. We've defined the appropriate prompt. Now what I need to do is basically pass in what query and context are going to be. So for that, I'm going to do dot format, and then I can do query is equals to query, and the context is equals to context. There we go. And that's pretty much all we had to do. So with this done, I can say that return the prompt back to me. So now what we can do is basically come to the bottom, and now instead of printing the actual context, we can say that now we're going to have a prompt which is going to be equal to generate rag prompt, and I'm going to pass it the query, and I'm going to pass it the context. And then what I'm going to do after this is just print the prompt to the console so that we can see what the actual prompt is in its entirety. So now let's run the script once more. Say who was Best Buy CEO, or who is Best Buy CEO, and let's see if we can get an appropriate prompt given back to us. So there we go. As you can see that it generated the prompt for us. The prompt contains all of the information that we extracted from the Chroma database with regards to the context. It also includes our actual question within it. And I can show you that. As you can see at the very top, it says, you are a helpful, informative bot. Then the question is, who was Best Buy CEO? And this is the appropriate context. And then we're waiting for the answer. So now let's do Control-C, let's exit out. And now we can do the last step, which is to take our prompt and pass it to the Gemini API. Here you can pass it to any LLM that you'd like. You can have a local LLM, you can have ChatGPT, you can do anything that you'd like. Langchain supports a bunch of different LLMs. We're just using Gemini because it's free and you don't have to use a credit card, so that's the benefit of that. But if you're interested in a tutorial for local RAG or local system, which allows you to chat with your PDF or other documents, let me know and I'll create a video on that as well. So let's create the function which will send our actual request to Gemini. So to do that, I will do the following. I'll say that we are going to have a function. It's going to be called generate answer. And this function is just going to take in our prompt. Then we're going to do the following. Firstly, I will import the Gemini API by doing import Google.GenerativeAI as GenAI. Then I can come back to the function and do genai.configure, so configure the actual SDK. And here I'm going to say that the actual API key is going to be equal to Gemini API key. And once that is done, the next thing that I'm going to be doing is setting up the model. So the model is going to be equal to genai dot and then configure the actual model. So that's going to be generative model. And here I'm going to do the model name is going to be equal to, and then we can do Gemini Pro. That's the one that I found worked best for my use case. And then you can experiment with other models as well if you'd like. And then after this, I'm going to do that the answer is going to be equal to, and then we are going to do model.generate content. And then here I'm going to pass it the prompt. And then once we have an answer given to us, I'm going to return it by doing answer.text. And that's all we had to do. And then finally, the last thing we can do is come back. And then here, once we have the prompt, we can do answer is equals to generate answer prompt and pass it the prompt. And then we can just print the answer, and that's all we had to do. So once this is done, the last thing that I'd like to do is before we actually start running the while loop, I'd just like to say that we are going to have a welcome text that the user is going to see when they start the actual process. So that is going to be print, and then I'm going to say welcome text. And this is going to be text that's generated using the actual Gemini LLM as well. So I'm going to do welcome text is equals to generate answer. And then the prompt here is going to be, can you quickly introduce yourself? There we go. So now when the user runs the script, as you can see, firstly, we're going to get a response of a general introduction given to us. So as you can see, it gives us an error, and that says that the response.text quick accessor only works when the response contains a valid part, but none was returned. So let's actually see what the issue here is. So I can do, can you quickly introduce yourself? Make sure that the question's correct here. And then do return answer.text. Everything looks good to me. So let's try it again. Maybe it freaked out by the actual prompt that we gave. But as you can see, now it worked, and it's telling me that it says, hello, I'm Gemini, a multimodal AI model developed by Google. I'm designed to assist and inform users to the best of my abilities. While I don't have personal experiences or emotions, I'm always learning and eager to help. Is there anything I can assist you with today? So now I can say, what would you like to ask? That's what we are saying. So within this query, I can say anything that I'd like to ask. So I can say, who is the CEO of Best Buy? Then send this information to Gemini, and then hopefully we should get an answer to this. Within the PDF, at the very top of this, we should have a whole page that's dedicated to the actual information of who the CEO is. But as you can see, it says that the CEO of Best Buy is Corey Berry. And now within the PDF, if I take you top, there you go. You can see a message from Corey Berry, which is the CEO. So we did get a correct answer. Now let's come to page number 31, so very far into our actual PDF. And let's ask, what were the net earnings? So I could say, what were the net earnings for 2023? And then send this information. And let's see if it generates an appropriate response for us. As you can see, it says that the net earnings for the fiscal year ended January 28, 2023 were $1,419 million. And as you can see, that is the correct information. So that's pretty much it for today's tutorial. I hope that you enjoyed and learned a thing or two about how to create a RAG-based system using Python, the Gemini LLM, Langchain, and Chroma DB. And now you can use the system to chat with any documents that you have and then derive answers based on questions that you might have for them. As always, if you enjoyed the tutorial, then please don't forget to leave a like on the tutorial and subscribe to my channel so that you get notified every time I release a new video. Stay happy, stay healthy, keep learning, keep growing, and I'll see you guys in the next video. Bye-bye.